So now let's look at the laws of refraction. First of all, we're going to draw our rays. So these are our rays without any refracting surface in the middle. And as always, we're going to draw our wavefronts. And I'm going to call them points A, B, C, D, E, F, and G, H, I. If I draw a refracting surface in the middle, let's suppose it passes through points D and I. Now I can write that the speed equals distance over time. So in my medium 1 with N1 refractive index and medium 2 with N2, I can say that the distance that light travels in medium 1 is CT1. And the distance that light travels in medium 2 is CT2. If I draw a normal to the surface here, this becomes my incident angle. But as we know that light does not continue forward, in fact, it will bend. So I can consider that light bends in this direction after it hits medium 2. So then I can say Fi as V1t, because I know this distance is 90 degrees. Now starting from point I, my new wavefront will be somewhat like this. So if I call this point M, I know this angle is going to be 90 degrees. Similarly, I know this angle is going to be 90 degrees for the incident ray. Then can I write dm as v2 time? So this means this is my incident wavefront, and this is my refracted wavefront. Now looking over here in this area, I can say that since this angle is theta 1, this angle also is going to be theta I. Then from my triangle, DFI, may I write sine of theta I equal Fi divided by Di, or V1t divided by Di. Similarly, in triangle DMI, geometry says if this is my transmitted angle, then that implies this should also be my transmitted angle, theta t. So then in triangle DMI, I can write dm divided by di, which can be rewritten as v2t divided by di. So from equations 1 and 2, I can rewrite 1 as di equal v1t over sine theta I, and di equal v2t divided by sine of theta transmitted. So combining these two will give me v1t over sine theta I equal v2t over sine theta t. This means since the times are the same, they will go away. And what am I left with? v1 sine theta t equal v2 sine theta I. And since v equals c over n, I can replace this as c sine of theta t over n1 equals c sine of theta 1 over n2. And we can rearrange this to give me n1 sine of theta 1 equal n2 sine of theta t, which is again the Snell's law.